the tone, please state your name followed by the pound sign.
Watershed.
Your line has been muted.
Accotink's watershed, it's 28% impervious, and it's mostly covered by MS4s. And I know all different states handle MS4s somewhat differently, but here in Virginia, the way we handle it is we allow our MS4s to delineate their service area, basically the drainage areas that carry the water to their conveyances. And so on the figure on the right, you can see in that tan color the combined service area of the 7 MS4s within the Accotink Creek watershed, and you can see that it has a pretty broad coverage of the entire watershed. It definitely covers the majority of the watershed. And given all these characteristics, it would make sense, or it's a fair assumption, that the biological community is severely degraded. In Virginia, we use our Virginia Stream Condition Index, or our VSCI, which is a multi-metric index to assess our biological health. Looking at benthic macroinvertebrates. And that scale for the VSCI ranges from 0 to 100, with the impairment threshold being at 60. So all scores below 60 are considered aquatic life use impairment. Now, in Accotink's watershed, those scores range between 26 and 32. So it is a severely degraded community, as you would expect, like I said, with these kinds of characteristics. So some of you Accotink Creek TMDL history. For those of you who are not, to kind of give you a rundown of the history, the first aquatic life use impairment was identified back in 1996. 2 more segments were added in 2008, but going back a little bit in time, in 1999 we were issued a consent decree after a legal decision where Virginia was brought to court saying you're developing these 303D lists, but you're not developing TMDLs to address those impairments. And so part of that consent decree was that we needed to meet all of the 1998 impaired waters list with TMDLs by 2010. And since this was first identified in 1996, Accotink Creek got put on that consent decree list. And so as we were nearing the end of the consent decree, we were working on a TMDL to address whatever was causing stress to the benthic community. And what we could identify with the data that was available then was that it was flow. You know, this is an urbanized watershed. There's a lot of stormwater conveyance, so there's an issue with flow. Well, as we were trying to deliberate what was the best way and what our legal latitude was to regulate flow, we were running short on our consent decree timeline, so EPA took over the TMDL and finished the flow TMDL, which was then challenged in court because it was an expensive TMDL to implement. And it was actually, the final decision really came down to a technicality that flow is pollution and not a pollutant, and TMDLs can only be developed for pollutants. So in 2013, the district court remanded it back to us, and we started anew in 2014, and that's where the chloride discussion comes in. So during that time, a lot more data was collected. And when we went back and started this project fresh to look at what were the stressors of that benthic community, we had a number of different data sources, including USGS, EPA, Fairfax County, and of course our own data. After we went through that stressor analysis, what we concluded was there are 4 most probable stressors of this benthic community. The first 2 are non-pollutant stressors, and they're hydromodification, habitat modification. So we couldn't develop TMDLs to address them. We could only suggest best management practices to address the next stressor, which was sediment, that we did develop TMDLs for. We could suggest that maybe some BMPs to address sediment should also be tailored towards addressing those non-pollutant stressors. But what's totally new this time around compared to the former TMDL development process is this new most probable stressor of the benthic community, which is chloride. And so we developed the TMDLs for sediment and chloride. And as part of identifying chloride as the most probable stressor, we were using our chloride criteria, which we adopted the EPA 1988 chloride criteria, which has an acute criterion of 860 milligrams per liter that's not to be exceeded as a 1-hour average more than once in a 3-year period. Similarly, there's a chronic criterion that's 230 milligrams per liter as a 4-day average that's also not to be exceeded more than once in a 3-year period. So looking at the data, we saw that in the upper watershed of the Accotink watershed, there were a number of chloride criterion exceedances. Now, looking on the right here, that's kind of the way we divided up the watershed, upper Accotink Creek there in the lighter green, Long Branch Central there in the gray, and then lower Accotink Creek in the dark green. All of our data that supported that chloride was the most probable stressor was in the upper Accotink watershed. So when we brought our stressor analysis to our stakeholder community, there was a lot of feedback saying, how do you know what's going on in Long Branch and lower Accotink if the data is only in the upper watershed? We had a fair assumption that we knew what this was coming from. It was coming from salt application, and that salt application isn't only happening in the upper Accotink Creek watershed, but to meet them with their valid concerns, we conducted a study in 2016 in the winter of 2016 to see if this was also happening in other parts of the watershed. And so here's a table containing all of the chloride criterion exceedances within Accotink Creek's watershed, and as you can see there, all data prior to 2016 was all USGS data in the upper watershed. But with that 2016 study, we were able to see a number of different violations, exceedances of the criteria in all three watersheds. So we had confidence moving forward that we could develop chloride TMDLs for all three watersheds, and that would be addressing this water quality issue that was widespread throughout the watershed. Now, part of that study that we did in 2016 was to also look at chloride compared to specific conductance. And here's a few figures of the chloride data matched with coincident-specific conductance measurements. And one thing that really emerged to us right away that was really interesting was in each watershed, we kind of thought they would behave differently, but they really didn't. The regression equations were all very similar, and they all had a lot of good strength to them as well, so we decided to pool them together to use them to predict chloride concentrations from specific conductance. And so this is that combined graph right there. Using that, we were able to look at the continuous monitoring of specific conductance in the watershed. There were two USGS gauges that spanned more than a year's worth of data, and during that 2016 study, we deployed one in the lower watershed, so we were able to see how each of the watersheds behaved through estimated chloride. And looking at this data, where we were estimating chloride from specific conductance, what we were able to conclude pretty quickly was the elevated levels of chloride were isolated to winter months, and the spikes in conductance, and therefore chloride as well, were always following winter precipitation events. So it was an easy conclusion, this is a winter stormwater issue. As we were looking at the data too, we started to realize, whoa, each one of these events kind of has a unique signature, and that's something we should consider as we're developing this TMDL and tackling this difficult pollutant. So looking at the figure on the bottom, that's the continuous monitoring throughout the 2016 study. And in the later part of January, we had our Snowmageddon, where it brought about 20 inches of snow to Northern Virginia. And what you'll see there is there's still a peak that crosses the acute criterion, but a long period where we're exceeding the chronic criterion as well as it tapers off. And, you know, that could be dealing with the long melt process because there was just a lot of snow on the ground, but also the fact that there was probably continual application of salt throughout that melt period. Now, going a little bit deeper into time, President's Day weekend 2016, we had a winter storm event where it started as snow, transitioned to sleet, and then ended with rain. So all the salts that were applied on the road, however well the practices were used to apply that salt, it led to enormous spikes that went up really quickly and went down really quickly. So what we concluded from that is that every event is unique, and we need to consider this in the TMDL development. Well, as we were going through TMDL development, we had our first attempt where we used an HSPF model, and we estimated application rates based off of our Department of Transportation's purchase records of salts. When we brought that draft model to our stakeholder community, our technical advisory committee, they were really uncomfortable with the assumptions we were using. Not only were we rebasing application rates based off of one applicator in the watershed, but we were getting very precise with something that's a lot more messy than that. And moreover, with the public safety concerns that come with what salts provide for us, our stakeholders recommended we look up north to Minnesota, where they were working on a TMDL, or a set of TMDLs for the Twin Cities metro area, where they were calculating the TMDL by using modeled flow times the chloride criterion. So we went back to the drawing board, thought about it some more, and said, hey, you know what, let's get even more simple with this. Our biggest concern is that somebody can say, this MS4 has stormwater that's coming out above the criterion. They need to ratchet back their application or stop it altogether. So we try to make really simple TMDLs and drive our focus more towards collaborative implementation of those TMDLs and a collaborative development of a strategy to implement them. And so in that, we made sure that there were no % reductions. And a lot of this was to give deference to the fact that this is a difficult pollutant and something that we need to consider seriously, but put our heads together and more of our energy towards the implementation strategies than developing complex TMDLs. So with that, just basically showing them there, we aggregated our MS4 waste allocations and our industrial stormwater waste allocations, and we just kind of left it like that, again, to tee up a more collaborative development of implementation strategies. So I've been talking a lot about chloride TMDLs and how we develop them, but it's important to acknowledge why salt matters. Of course, we know, and the whole reason we developed the TMDLs is that it's toxic to fish and the bugs in the stream system. But it's also corrosive to infrastructure, vehicles as well, and it also affects public health in both. If you get your drinking water from a source that's contaminated with salts, well, if you're on a salt-restricted diet, say you're on dialysis or you have heart disease, well, that's an important consideration. Sometimes your water is something that you can't drink given your restrictions. Additionally, if your public water supply is drawing its water from surface waters, and those surface waters are contaminated with salts, well, those salts play a role with corrosion within the pipes, and depending on how that management goes, it brings about public health concerns. Considering all those negative impacts, it's obvious that there are a lot of positive benefits from salt as well, and most important is the public safety that it provides, but also the public access, the continuation of commerce during winter storm events, and the ability for people to get to their jobs during winter storm events. So it begs the question of, is there a balance that can be struck between these impacts and these benefits? And looking to other jurisdictions who really charted the course on this, we feel confident in saying that, yes, there is a way to strike a balance here. And so what we're going to try and do is strike that balance through the development of our salt management strategy, or our SAMs. And that SAMs is going to focus on an improved best management practice, awareness, and implementation. And as we're going through this, you know, the lessons we've got from talking to people in states up north is that this needs to be a stakeholder-driven process. And that's important for a number of reasons. Firstly, for Virginia DEQ, regulating or suggesting best management practices for salt application is a new realm for us. So we need the experts' input there to understand the nuances of these practices. Also, as you're going to hear me say over and over again, we need to be sensitive to the public safety concerns. But most importantly, as you'll find out on the next slide, we've expanded the scope beyond just the Accotink Creek watershed to being a broader area in Northern Virginia. And so because there are no regulatory hooks there, what we need is stakeholder buy-in to ensure the success of this initiative moving forward. So here's a map. You guys are well familiar now with where Accotink Creek falls in the geography of Virginia, right there just southwest of DC. But there's this broader area shown here in blue that represents our SAMS project area. And the reason we expanded this was first based on an assumption that your salt application practices are not confined to watershed boundaries. There's no acknowledgement of a watershed as you go down the road or as you maintain this property in this watershed or that property in that watershed. So the practices are probably consistent across watershed boundaries. So then we started looking at the data around the region. And again, looking at specific conductance, here's a 10-year record for dead run. And what we saw was similar behavior compared to what we saw in Accotink. You have spikes isolated to the winter months, and I guarantee you each one of those spikes in conductance is related to some sort of winter precipitation event. And this wasn't only the case in dead run, wasn't only the case in difficult run, wasn't only the case in flatlick branch. It was all throughout the region where we had the data available. To add some justification to that, as part of our integrated report, every few cycles, we develop a trends analysis. We have a network of trend stations that we visit regularly and measure a number of parameters at, one of which is specific conductance. Well, for our 2018 trends analysis, which is still draft at this point, what we were finding was throughout the SAMS project area, 2/3 of our trend sites, shown here by both the stars and the blue dots, the stars are just over the blue dots, 2/3 of those trend stations in the SAMS project area were showing statistically significant increases in specific conductance. And not only was that a large proportion of the sites, but it's evenly distributed throughout the SAMS project area, giving us extra confidence that expanding the scope of this project area is going to allow us to get ahead of an emerging water quality issue that we haven't identified as, say, a chloride impairment that needs a TMDL. One last piece of justification for deciding on these 9 cities and counties that make up the SAMS project area is, one, it's the same boundaries as our Northern Virginia district for our Department of Transportation, which is also the same boundaries as our State Police Division 7 boundaries up there in Northern Virginia. So we're trying to line up some of our governmental jurisdictions as well. Now, in terms of our SAMS development, this slide's a little outdated. We had our first real development meeting this past Tuesday, and there's a lot of discussion and minor changes to these goals and objectives, but they're all going to be about the same gist. And of our goals, of course, one of the most important ones is to develop a strategy to address the chloride TMDLs and also to get ahead of this water quality issue in the Northern Virginia region. Second goal, and this goes back to that whole idea, that really strong focus on stakeholder buy-in, is to generate long-term support for these practices. Again, we don't have any regulatory hooks just yet outside of the Accotink Creek watershed, and we'd hope that by proactive adoption of these best practices, we can preempt or defer, or we can defer additional TMDLs in the area. And then lastly, which is very much in line with the mission of DEQ, is to improve water quality in this Northern Virginia region through the implementation of these best practices. Now, in terms of the objectives, the way we think we're going to do this is, first and foremost, and probably most importantly, developing a suite of these best practices. Secondly, we need to have some sort of guiding document to outline all the elements of the strategy. Some of those elements, which include the next objective, a comprehensive education and outreach campaign. That's not only to the general public, that's not only to the SALT applicators, but that may also be to the politicians in the region. As we're finding out, a lot of these decisions are political decisions. So the more we can bring up the knowledge on this issue in the region, and the more we can get people to understanding the different practices, perhaps the more successful this will be. Also, one of the objectives is, of course, to explore funding opportunities, because implementation is never cheap, and we need to find some ways to help fund it, or perhaps even incentivize it. And then lastly is developing options for effectiveness monitoring and ways of either tracking salt usage or the integration of best management practices into operations. So in terms of developing this SAMS, like I mentioned, we're just kind of getting started on it. Back in January, we had our first public meeting with all sorts of things, be it TMDLs, TMDL implementation plans, or in this case, this salt management strategy. We always kick them up with a public meeting and a 30-day public comment period. So that just wrapped up the comment period in the middle of February, and just this past Tuesday, we had our first Stakeholder Advisory Committee meeting. Now, the Stakeholder Advisory Committee, or the SAC, is really the group that's going to be developing this strategy. Each member of that committee is going to break out into different work groups, and you can see the anticipated work groups on the right here. The reason we specify anticipated work groups is we really want the stakeholders to drive what the decisions are here, and this is what we're proposing for discussion and deliberations at our next SAC meeting. Anyway, as those SAC members break out into the different work groups to have their own work group meetings, these are going to work on the individual recommendations of the strategy, each different element within the strategy. Once those recommendations come back from the work groups, we'll bring them back to the SAC, try and find consensus, and once we have consensus on the final document, we'll then bring that SAMS document to the public again with another public meeting and a final comment period. And we're seeing this as a 2-year process, acknowledging that there is probably good potential for it to expand over time. Now, before I go into the next slide, it bears mention that a lot of our work groups that we're proposing to our SAC line up a lot with our objectives, but one that might be kind of, or two that might be kind of popping out to you is the difference between traditional best management practices and non-traditional practices. And this was a perspective that we gained from looking at what Minnesota was doing with their Twin Cities metro area chloride management plan. So this is a list that's adopted from that plan. If you get a chance, it's a great plan to look through. Really brought us up to speed a lot. But anyway, on the traditional side, this is best practices dealing mostly with salt application. what kind of training can get for better salt application, what kind of storage, what kind of equipment, those kinds of things. On the non-traditional side, which includes the legislative options, this is looking more at different things like lower levels of service, which roads get treated first and which roads get treated within a day, et cetera, how quickly does a parking lot need to be cleared, et cetera. And then down in the legislative options, there are things like winter weather speed limits, and then possibly taking a page out of New Hampshire's book with their Green Snow program, which is a training program for private applicators that if they do everything to, what they learned in their training and they document their work, then they should theoretically be free from slip and fall liability. So a lot of things to consider here, but we wanted to split out the traditional practices from the non-traditional so that we can really allow time to deliberate over what we're going to suggest as our final strategy. So maybe beating a dead horse here, but again, stakeholder engagement is something that's really important to us with this process. And part of the reason there is that this water quality issue is really unique. The public, first of all, is really familiar with this pollutant and interacts with it a lot, not only in actually applicating it on their own property, but demanding its use. In Northern Virginia, there are high expectations of transportation the second the snow stops falling. So there's a lot of interaction there with it. Also, it can't be said enough, the crucial public safety that these salts provide is really important to consider, and we need to make sure all voices of concern are heard. And then lastly, like I said before, because this is a new frontier for us, we really need a lot of outside experts to come and bring their knowledge to the table. And so in terms of stakeholder engagement goals, one, we want to make sure that the public is aware of this issue in ways they can make a difference, but then also really, most importantly, bring a broad representation of stakeholders that are related to not only the use of the salt, but the impacts of the salt so that we can get all these potentially conflicting and potentially agreeing perspectives at the table to do our best to balance all their needs. So in terms of that stakeholder advisory committee, we went through an extensive outreach campaign to try and get a bunch of different groups at the table. And on the left there in the black font is our traditional groups we reach out to, but on the right was the new group of stakeholders that we really haven't worked with much in the past, and that's the property owners and managers that actually deal with the contracting for these winter maintenance services, the actual winter maintenance service providers, water purveyors, because they're impacted by this as well, and then also public safety officials like the state police. In terms of what our stack looks like right now, we have about 50-some members, and the distribution in terms of members is a little bit skewed to the MS4 side, but that's because they have a lot of representation there. On the right is a figure showing the number of organizations or entities that are represented. It's about 30-some. One thing that we acknowledge we're really lacking on is folks from the winter maintenance service providers sector. We have one representative on there, and we're trying to do our best to beef up that representation because we really think they have a lot of interesting thoughts to offer and a lot of interesting perspectives to contribute. Again, maybe beating a dead horse, but we really wanted to show the stakeholders that we're interested in their input and not just input that we'll consider what we think of it, but input that we're all going to collaboratively work to. And so as we started this process, we put out a stakeholder survey. We distributed it to all the folks we were inviting to be a part of the stack, as well as invited them to share it among their networks. And we asked them a number of different questions. There was only 11 questions, but generally what we were trying to figure out is, are people concerned about this issue? How familiar are they with the issue? What's their role related to salt? And then are they in agreement with our objectives as we propose them? And what we found very encouragingly, and this idea was supported by the attendance at our first SAC meeting and the enthusiasm at our first SAC meeting, is that there's everybody's in basic agreement that there's an opportunity to reduce salts while maintaining public safety. But there's also a lot of concern in the group about this issue. In fact, almost half of them indicated that they're very concerned, the highest option of concern we offered. Also very encouragingly, all the participants were mostly in agreement with all the objectives we were proposing, most importantly and pretty obviously with support for a suite of best management practices, but as the limitations of surveys go, once you actually ask them the question of what do you think of the actual wording of these objectives, we found a lot more diversity in there, but at least there's general support for them. So just to give you an idea of how long we see this working out, Again, it's about a 2-year process. We just wrapped up the first SAC meeting. The second SAC meeting will be there in the beginning of the second quarter of 2018. And then we go into the actual nitty-gritty work in the work groups. And one of the things we found out at the first meeting is there's a knowledge gap in our stakeholders. And so while we have all these SAC meetings and all these work group meetings, one thing we're realizing we're going to have to do in between is offer some sort of training to bring everybody up to the same understanding of what are these practices we're talking about, what are these impacts we're talking about, make sure everybody's aware and talking the same language. And so also you may be looking at the fact that, hey, you're only having 3 work group meetings. How are you going to get a lot of development of recommendations for these strategies? And we acknowledge they probably will stretch out. We may have more than just 3, but we're also trying to really economize the use of time between meetings using different survey tools and whatnot to find consensus on things we weren't able to resolve during meetings. So it's an evolving process, but this is at least how we're seeing it right now, wrapping up at the end of 2019. And so before I finish, just the last thing I wanted to share is we have this SAM's webpage. It's our project webpage really to host all of our resources, but also as kind of an engagement opportunity. We have a number of background resources on there, a way to sign up for newsletters, which we plan to start sending out here soon, different project updates, and then a whole other page tied to it where we're listing every single bit of our meeting materials from the handouts to the presentations. Taking a note out of the books of our predecessors who've really done a good job of charting the course on how to tackle this pollutant. And so with that, I can turn it to questions, or depending on time, I can wait till the question session at the end.
All right, thanks, Will. We do have one question. We have time for a couple more if people want to type any of them in. The first question was, MS4s don't seem to abut most of the stream corridors, and they're just wondering why not.
That may be mostly due to what drains their actual conveyances. The development, I assume this is talking about the Accotink Creek watershed image, and in that area, while it's highly developed, it's highly suburban. So there's a lot of private property that abuts up to the streams and a lot of parklands that abuts up to the streams. And the actual conveyance networks that takes the waters off the roads and the other more highly developed commercial areas aren't necessarily right next to the streams. So that may be why it looks that way, but again, because our MS4s can delineate their service area, what's draining to their conveyance structures, that's why you kind of get that area next to the streams that's left unregulated.
All right, thanks. I'm not seeing any other questions at the moment. So to everyone, if you have any questions, keep sending them in. And we just got a couple more, I think. What sources did the TMDL find for load allocation?
So again, we took a really simplistic approach to that. We know that outside of what we regulate, the stormwater sources are probably coming, with regards to chloride, are coming from those private applicators. And so while we didn't put that explicitly in the TMDL, we just, really the way we developed the TMDL was it was a load duration curve at the watershed outlet. So how much the loading capacity was for the watershed, and then based on the aerial coverage of the industrial stormwater permits and the MS4s, that's how we allocated the waste allocation. And then the remaining proportion of the watershed was just given to the LA. But we do acknowledge, and it's been something we're really working on, like I was saying, in the salt management strategy, that those private applicators are an important piece of this pie, and we want to bring them in as much as possible to try and get their contributions and try and meet them where their needs are as well.
Okay. And can you just please state again what the chronic and acute chloride levels are?
Sure. I probably said that in a really convoluted way. But so the acute criterion is 860 milligrams per liter of chloride. That's a 1-hour average, and it's not to be exceeded more than once in a 3-year period. And then the chronic criterion is 230, I think, milligrams per liter. That's a 4-day average that's not to be exceeded more than once in a 3-year period as well. And these are, for reference, the 1988 EPA criteria that we adopted in Virginia.
Okay. It's time for a couple more. Does that area have an issue with water softeners?
Not to my knowledge. That was something we've been asked about a lot. I don't believe there are a lot of water softeners, but the other thing is that there are no wastewater treatment plants discharging, and no, I think there were 2 or 3 single-family home dischargers in the watershed, but most of the water or the wastewater in that area is transported out of the watershed and down to the Potomac. So at least in terms of the way the water softeners could be impacting it in Accotink, that wasn't a problem.
Okay, and last one, and to those whose questions I didn't get to, we will address them after the next presentation. But how is residential well salt contamination being addressed?
Not specifically. You know, one of the big lessons we've learned about salt is that once it's in the environment, it's incredibly energy intensive to get it out. The only options you really have are reverse osmosis, and I think I heard something where there's more wastewater that comes out of that than actual drinkable water. So our main strategy here is to reduce the application, do our best to reduce that, and hope that the impacts on the environment are a reduction in the impacts, including on drinking water wells. But again, in that area, most people are, it's a highly developed area, and most people get their water from the public water authorities.
Okay. All right, thanks. And we will get back to the rest of those questions following the next presentation, but now I'd like to move on to a presentation from Stephen. So I'm passing you presentation control now.
I've got it, Jasper. You can hear me okay?
All right. Yep.
Okay, then I will jump right into it. And I think I'm taking a slightly different view of this than Will. He's talking from the regulator side, and I guess I'm speaking more from the regulated community side. So I'm going to talk about implementing a chloride TMDL, or actually we think that it's a single TMDL, but it's actually a series of TMDLs in chloride TMDLs in northeastern Illinois. Jasper, my slides aren't advancing.
Should be a page up and page down, or the space bar.
Yeah, the space bar is what worked in practice, but it's not doing it.
Did you accept presentation control before moving to full screen? Or click on the slideshow and then try it.
Presentation control. I don't know if it take me through the presentation control.
1 second, I'll take it back for a second. All right.
Okay, so it came up that I'm not a presenter.
Okay.
Yep. Okay, that's working now. So I'll just continue with this slide. But the previous slide was just showing what our organization is. It is a nonprofit organization that works on trying to find cost-effective ways of implementing TMDLs and meeting the goals of the Clean Water Act. It's made up of wastewater agencies, MS4 districts, environmental organizations, and environmental engineering companies. And it is a JEWS-supported organization. We also have a large number of departments of transport type organizations, including the Illinois Tollway and Illinois Department of Transport, and that is because of our work on chlorides. So a quick introduction to the project area. This essentially is the collar area to the city of Chicago, so it's the suburban area around the city. It's a 360 square mile area made up of 3 principal watersheds, which are the Salt Creek, East Branch, DuPage River, and West Branch. And no puns about Salt Creek in this criteria. It's a very hardened watershed, and as we move out from the city of Chicago, we've got areas that are 30% impervious, moving down to about 15% impervious as we get to the western boundary of the watershed. We have 8,000 road miles of in the area, and we have over 55 municipal entities, each one of them holding a MS4 permit. And there also is a number of smaller organizations, township, highway departments, etc., who also hold permits and have responsibilities for snow and ice control. This is a pretty typical view of the type of landscape we're talking about. Of course, as I mentioned before, we have a high density of roads throughout the area. But what I wanted to capture in this photograph is when I talk about roads, I want us to not just think about roads, but also want to think about parking lots, sidewalks, all types of transportation surfaces that receive anti-icing compounds during the winter months. So Will had talked a little bit about the water quality standards. Illinois, which you can see in the table there, has a slightly different type of standard than other states, or indeed the national criteria. It has a single 500 milligrams per liter standard. I've listed here as the chronic, but it's not. It actually could fit into either category. We don't have it broken out into chronic and acute standards. And it is obviously higher than the chronic limit that we typically have. And I put another couple of examples in there just to show you the kind of range of chronic and acute standards that we're seeing throughout certainly the Midwest and federally. So here's a simplified map of our 3 watersheds, and this is what we were facing in 2004 when the TMDLs were approved. We had 7 reaches which were listed for chlorides, and TMDL developed for those. We also had total dissolved solids and conductivity. Basically, all of those are for chlorides. It was chlorides that was pushing all of those items above the water quality standards. So they were all grouped together under the chloride item, and we had essentially 10 reaches or 10 segments in these waterways, and I've highlighted them here in red. You can see in the other blue are assessed segments that did not have a chloride TMDL developed. Now, at this point, as the regulated community, we did not look at these individual segments. We essentially made the decision that the entire area was going to be impaired, and I think that matches what Will's conclusions were. Basically, if you have an urban area inside the snow belt and you have a snow and ice operation using chlorides, you are going to have water quality violations. And I think that you should start from that assumption until you have proof that it's otherwise. One of the things that maybe stress here, so we went to implement this, is that the TMDL set out that it was winter de-icing operations that were causing this. It was a non-point source action. Typically TMDLs are not very good at enforcing actions against non-point sources in the Midwest. So we made the decision that we were going to progress and implement the TMDL. And we had a number of reasons for doing that. One, we were worried that in fact it was going to end up at wastewater treatment facilities. Will had already mentioned that there is actually, for practical purposes, no way to remove chloride from the water column once it's in there outside of reverse osmosis. But there was some worries that perhaps that would be required on wastewater treatment facilities. But on the other hand, we were embarking on a major program for improving aquatic life in the watersheds, and we were pretty sure at that point that chlorides were in fact a major impairment for, or a major reason that our aquatic life was not all that it might be. And I think the last item then was that it was clear that chlorides had a major, there were costs associated with chlorides. A few years ago, the University of Minnesota released a study that suggested that at 1 ton of chlorides could cost between $1,200 and $3,500 once it was applied, and that's all the costs from purchasing it to the damage to infrastructure, vehicles, and the environment. So we could see from a public policy point of view in terms of hitting the aquatic life goals and lowering the amount of damage it was doing to our built environment that this was probably a pollutant that we wanted to work on. And it's one of the few pollutants where you can actually save money while working on it. Phosphorus, etc., really don't fit that profile. So we re-examined the TMDL. TMDL did not have allocations for different communities. It basically just had a reduction target to be hit throughout the areas around the, we extrapolated it out to the whole watershed, and what it was suggesting was that in the various watersheds we had percentage reductions. Upon examining the assumptions behind the TMDL, one of the things we noted was that it was it placed a 200 pound per lien mile assumption that that's what our snow fighting operations were using as a standard application application rate for chlorides. That did not hold up under empirical examination. We talked to each of our local agencies, and what we found was that they were actually applying more in the region of 400 or 500 pounds per lane mile. So that immediately moved the, or gave us a larger amount to climb. As you can see here, if you look at the table at the bottom, the target set for the TMDL was 13,300 tons, and these are tons of chloride, not tons of winter or of sodium chloride. This would be 60% of what that total would be, chlorides being 60%, approximately 60% of a sodium chloride unit. The TMDL suggested that we were currently putting in 15,500. Our re-examination of the assumptions of the TMDL suggested that we were actually, public agencies alone, were putting in over 32,000 tons of chloride per year. So this was quite a sobering exercise to run through. The other thing that we looked at then was to re-examine, the TMDL had put the source of chlorides as being, or perhaps more accurately, winter violations of the chloride standard at the feet of winter de-icing operations. We set out to examine that. This is data from the TMDL, as you can see here, during that whole period of 65 through to 2004. There were only 2 recorded violations of the water quality standard. What became clear when we started looking at it was that these violations, of course, most of the monitoring takes place during summer months. And it's very important when you're looking at this pollutant that you differentiate between warm weather months and cold weather months. There's a vast difference, and I don't think there's many other pollutants that we get such a drastic change in concentrations between those 2 months. I'm not going to spend too much time on this because Will's already covered it. We also set about doing conductivity monitoring. It was a very cost-effective way to gather a lot of data cheaply, rather than doing grabs continuously, which really was a large drag on both staff time and financial resources. We also set up found, as Will was pointing out, an excellent relationship between our conductivity and observed chloride concentrations. And this is an example of the type of data that we were able to generate from this. This is for, as you can see here, from running from the winter of 2007 and 8 through to the winter of 2013 and 14. We continue collecting this data, but these graphs get a little busy if we keep on putting it on there. But as Will's graphs were showing, we see this pattern where we have relatively low chlorides coming into the winter months. We get to beginning of December, we get the first snowfall, we get the first call-outs, and instantly we get this spike. And then we're pretty much above the state water quality standard for the rest of the winter. Pretty convincing evidence that, in fact, it is winter snow and ice operations that are causing the violations of the water quality standard. We also gather data as part of our, what we call a bioassessment program, where we're linking, or evaluating stressors to aquatic life and measuring aquatic life biodiversity throughout our area. And we gather this data using grab samples, so this is a second data source. And what you're looking at here is summer chloride concentrations for 3 years in one of our basins. And what I want you to note here is the slope of the best fit lines put into this data. And you can see in all of those 3 years, we see this tailing off of concentrations as we move through from May, when we start this process, all the way through to October. And what this shows is that when we use these winter de-icing compounds, they're not, these are river systems, they're not lakes, but they're not leaving these river systems immediately or even a few weeks afterwards. We can still see the impacts of these compounds on concentrations getting through into October, even through into November of the following year. And one of the things that we're not really going to discuss it a lot today, but we're evaluating is are these observed summer concentrations perhaps more important than the winter concentrations because of their impacts on aquatic life. That's something we're going about studying. We also looked at wastewater treatment facilities, and for the moment, I'd like to look at the two boxes along the top and the one at the bottom right-hand side of the screen. This is the typical pattern we observed at our wastewater treatment facilities. That they were typically putting out effluent that was less concentrated than the observed summer values in the waterways. The one exception, and the reason I picked these particular plants was because of this exception, the village of Bartlett, the bottom left-hand side, was markedly more a higher loading than we observed at the other plants. And the reason for that was the village of Bartlett lies at the very western side of our program area, and they have a lot of well water. The rest of our plants are typically, there's a large interbasin transfer of water coming in from Lake Michigan, which is a very low concentration of chlorides, 12 milligrams per liter. But the village of Bartlett is at the edge of that area, so there's some of their clients are using Lake Michigan water, but a lot of it is coming from wells. And that water softener, of course, we know has a very concentrated brine, and that's what we were seeing there. So I think one of the things today, we're saying that in our area, wastewater treatment plants were not a cause of water quality violations or, contributing, at least as we can see it at the moment, to an impairment on aquatic life. That may not hold up in your particular area. One other item that's worth considering is impact on drinking water. This is not from our program area. Well, it's sort of a more general study that was done by the state of Illinois. And it was looking at drinking water or concentration in drinking water wells and the white is 100 feet from, or less than 100 feet from a roadway, and the red is 100 to 200 feet away from the roadway. And you can see the concentrations are higher in the, with concentrations increase as we get closer and closer to the road system. And they're increasing, concentrations are increasing at a faster rate. So what can be done about any of this? The 2004 TMDL did give us some guidance on what might be done. It suggested that we should look at alternative compounds, that we should look at calibrating vehicles, and that we should do some training. We reworked this, these guidance, as it were, into sort of menu of activities that we felt would be would reduce salt use in our area. And it was a literature review. We looked at what was going on in Canada, we looked at what was going on in Europe, and we looked at what was going on in Minnesota, for example. So I'm not going to go through all of these. I'm just going to pick a couple that I think have been particularly useful, and some of them do not require an investment on part of the community. For example, we do stress that communities should look at level of service. We think that that is the fundamental item here, and we don't dictate what those levels of service should be. We simply suggest that it is good practice to have a level of service on the books. I think a lot of communities find that they had really never thought about this. They would just go out and remove as much snow as they possibly could, and I think what we were finding was that the default there was often that resources were overused, and that a lot of communities were in fact overperforming. So what we're suggesting is that they review the level of service, what level is good enough for the various streets. For example, if you look at the top left-hand side of the screen, a residential street need not meet the same level of service as a interstate highway, like we see at the bottom right-hand side of the screen. The other thing that we stress is that all vehicles and snow application equipment should be calibrated. This is something that we were a couple of years into this process before we realized very few of our members were doing it. So we rounded up calibration charts, and we held a couple of workshops where we focused on this, and then we, just in a moment, we went out and tracked it, and we found that calibration use had increased. So calibration is basically just checking out that the equipment is putting down the amount of salt that you think it is, and the community, of course, has a number of horror stories about brand new equipment being purchased, and after it was calibrated, finding out that the application rates were sometimes 100, 150% higher than what the equipment or the setting was suggesting that it was placing down. And obviously, you can't run a program if you don't know how much material your equipment is actually depositing on the road surface. We also spend a lot of time doing driver training. We talk about what the driver can do simply from being conscientious. Certainly monitoring vehicle speed is a big one. There was a study from Michigan DOT. They found that the three principal factors that were affecting bounce and scatter, so this is where a salt will hit the road surface and then bounce into the curb, and it's no longer on the driving surface, so it's essentially lost from a public safety point of view, but it does add to our waterway loading. They found that vehicle speed was the principal factor or variable that affected that. And the lower the speed, the less bounce and scatter you had. And then it was the type of applicator that you had, the type of spinner you had at the back of the vehicle. And then was the product wet or dry, with wet being preferable over dry in terms of bounce and scatter. And that is just a summary of some of the findings from that study. We also have done a lot of training for our members on the chemistry of the various de-icing compounds that are commonly used in snow and ice control. And these, of course, are sodium chloride, mag chloride, and calcium chloride. Things that we're stressing is that at certain temperatures, these products are no longer useful. Calcium chloride obviously has a much lower eutectic temperature than sodium chloride. And when I'm talking temperature here, which is another thing we stress, we are talking about pavement temperature, not talking about air temperature. As a result of this, we've had a large increase in the amount of communities that are monitoring the surface temperature of their roads as opposed to just taking weather forecasting ambient air temperatures. We also stress that the putting down more of the product is not necessarily an improvement because increased concentrations of chlorides do not lead them to work more efficiently, as these diagrams show. Just anecdotally, from back in 2013, we had a very long extended cold period, and we had a number of our communities that were being told by law enforcement that they had to go out and apply compounds, and they were able to the road surface because there was dangerous levels of ice, and they were able to point out the fact that none of the compounds they had available would actually break that ice, and that this had become we had to get the vehicles to slow down. So that meant that a series of good decisions were being made while maintaining public safety instead of just scattering chloride on the ground so everyone felt that they needed to do something. So then we'll move on to the other BMPs that we have popularized throughout the TMDL area. And the first big one was treated salt. This is also something that we've been stressing in our trainings. This is where you apply a liquid to the dry salt, so it is wet. There's a number of reasons for doing this. Studies have shown that you can affect a 30% reduction and get the same results as using dry salt once you have a liquid applied to the salt. And there's various ranges of how much liquid you're going to apply depending on what your objectives are. At first, this is the way that we were doing it, which was applying it with a hose and then mixing it up using a grater. But as we've moved on through this process, we've been working on this now for 10 years. There's been an evolution on this, and here you can see one of our members using an escalator and a fantail spreader to apply a carbohydrate mix to the dry salt. The gold standard of these application BMPs is the anti-icing, and this is where you apply a liquid brine to the road prior to a storm. The reason for doing this is that studies have shown that if you can prevent the ice from bonding to the pavement, you can make a 75 to 85% reduction in the amount of salt that you use from trying to use salt afterwards to break that bond once it's already bonded. This has become very popular through our area, and we'll see in some of our tracking analysis, we can see how this is probably the BMP that has become the most popular throughout the TMDL area. This is a test run that was produced by County DOT. I'm sure you can tell which side with the anti-icing was a flag. Anti-icing has also been attached to a 85% reduction in crashes. What we have is some members will do spot applications of it, so they will apply it to bridge decks, stop sign areas, or areas with traffic lights, anywhere where you're going to have a braking surface or the road is elevated, and likely the surface temperature is likely to be lower than the surrounding road. So our method for doing this is we hold a series of technical workshops. We're running at about 3 to 4 per year. These technical workshops, we invite speakers both nationally and locally who will tackle these core areas. We'll talk about the TMDL, we'll talk about the reasons for doing this, and then we'll go through technical presentations on how this may be done, including hands-on calibration demonstrations and such. These workshops have been very popular. When we first started off, we had about 100 people attending the 2 workshops that we hold. One is on roads, one is on parking lots and sidewalks. This year, we were up to nearly 300 people between the two, and that popularity is, despite the fact these workshops are now being replicated around our TMDL area. So we're happy with the way the workshop's going, but of course we need to know, is any of this actually working? So as Will pointed out, this is not so easy to demonstrate as one might think. What you're looking at here is results from a questionnaire that we turn out every 2 years. I have it from 2016, but I was unable to put it up because it just did not fit into the screen. The icons got so small it was kind of hard to tell what's going on. But essentially what we look for are things like beaches and liquid sodium chloride becoming more and more popular. And as I was saying earlier, what we've noted is that we've had a real increase in liquids. One of the things that initially confused us was that we were not seeing such a big reduction in dry sodium chloride, which you can see at the left there, dry NaCl. Being used, and of course that was initially confusing, but it's not a one-for-one type operation. In other words, a snow fighting agency may well use more liquids, but they may still use dry salt under some conditions. So one of the things that our questionnaire is going to have to try to evolve to do is to try to pick up, are you increasingly using liquids and phasing out dry sodium chloride, or are you kind of stuck at a certain plateau and not moving beyond that? The other thing that we look at is application rates, and what we're trying to do here is we're trying to move our members from the right-hand side of this chart, where they're at more than 400 pounds per lane mile, and move them into the lower part of the chart. And what we've had is that we've had a substantial move into the 200 to 300 pounds per lane mile category, and that, of course, that would suggest that we are using less salt during the year than the sort of non-intervention condition. This is data for a single agency. We track a number of agencies like this, but what we try to do here is show the use of salt versus some variables that would be proxies for the severity of a winter. That is the number of call-outs that agency had during that year and the number of snow inches encountered. This data through 2016-2017 suggests that this agency is using salt 30% more efficiently than they were back in 2007 and 2008. So we also look at waterways. As you saw, we had some substantial data from chlorides in the waterways, but this is also a very complex item to try to find if we're actually having an impact. As you can see here, these are what TMDLs are based on, chloride concentrations during our implementation period. We're seeing here 2006 through 2012 actually increased in the waterway, but if we look at loading, the waterway has actually less salt in it in 2012 than it did in 2006. Efficiency in snow and ice operations can only affect the amount of salt that they're putting down and be efficient with it inside the weather conditions that they're facing and meeting public safety goals. Chloride TMDLs and aquatic toxicity of chlorides, of course, are driven by concentrations. So this is improved efficiency is absolutely essential, but it's unpredictable what the impacts are going to be in the waterway based on winter weather conditions and summer weather conditions. This is just another graphic showing a similar item here where we can see that chloride concentrations and the observed loading in the streams do not track well. Why is it, I guess as water quality scientists, we're often used to solving for flow and looking at loading versus concentrations, but I think with chlorides, this is especially complicated. Here's just some of the factors that we've noticed that can impact the amount of salt that an agency uses during any given year. So we've already talked about the number of call-outs. That's how many events they had where vehicles had to apply compounds to the road surface. But there's also the scale of those call-outs. That can vary hugely. We've had some agencies that maybe send out one truck for a call-out, and then a next call-out, it can be as many as 8 or 9 trucks. There's also the duration and the type of storm. Application rates can vary depending on if it's a snowstorm or if it's an ice storm. And of course, pavement temperatures can also vary, and that can affect the type of compound that you might apply, and that also affects the amount of chlorides that then show up in your waterway. And then, of course, you may just have a very, very long winter, which would also affect the amount of chlorides that then move into the aquatic system. last thing I'm going to quickly talk about is a case study that we worked on starting back in 2012, if I remember correctly. At that point, there was a large infrastructure project that was being placed in the northern part of our watersheds. It was this is a multi-billion-dollar piece of infrastructure. It's called the Elgin O'Hare Western Access. So this project was being really pushed hard through permitting by the state, and we contested the permit on the basis that this was a chloride TMDL listed waterway. It was listed through a 3D list for having chlorides, and there was a TMDL developed for it. We had been working to reduce the amount of chlorides, and this piece of infrastructure was going to place thousands of additional tons into that waterway. This is a map showing aquatic life biodiversity throughout our area and how it is attaining the aquatic life use, and you can see the black lines across the top of the Salt Creek portion of it. You can see that is where this infrastructure was going to be placed. This infrastructure was being built by the Illinois Tollway, and they agreed with our critiques, and we found a compromise on how to move forward on this. And I just mentioned that they've been excellent partners in working on this. The result of the negotiation was the Illinois Tollway moved forward with an improving efficiency of their snow and ice applications, and their target is a 20% reduction throughout their entire network. But the other thing that they did was put in place a grant that our members could draw upon to improve their training of personnel and purchasing more efficient equipment. And the idea is that those communities will reduce their salt to the point where the additional salt coming in from this piece of infrastructure will equal zero. And we had our first 2 grant recipients this year, and we're working on a further 3 for this year. And that is just a detailing of the concept. And that is me out of time, and I'd be happy to take any questions.
Thanks, Stephen. Yeah, so if anyone can just send in questions, I'll relay them to both speakers. We do have one that came in for Stephen. The survey results are voluntary, and who are the primary respondents?
Yes, that's a good point. Actually, from our point of view, the whole system is voluntary. We don't have we're not a regulatory agency. We have to rely on making good arguments to get people on board. And yes, all the questionnaire responses are voluntary. And in fact, on our newer data set, that caused a couple of issues because we had a bigger response than we ever had, and we had an influx of new agencies. So some of our, where we were seeing BMP improvements, they kind of went into reverse because new agencies were coming on board, but they were not doing any of these practices. So it kind of diluted our data. So we had to start, trying to differentiate that a little bit more finally. But yes, the whole program, attendance at the workshops, uptake of the BMPs, answering the questionnaires is all voluntary.
All right, great. And to answer another question, yes, all of the slides will be put up on NUIPIC's website within the next few days, and you will be getting a notification for that. I do have a couple questions for Will, and if anyone has questions for Stephen, you can still send those in. So for Will, does the TMDL allow for expansion of roadways or take into account any add-a-lane projects?
Again, the TMDL was handled really simplistically because it was just assigning what the loading capacity was based on the flow distribution and the chronic criterion. It was modeled really simply, again, with a focus on implementation. If roads are to increase, which they will, that area is always developing, and I'm pretty sure I'm aware of a few plans in the area. If roads are to increase, then the same issue remains. The DOT, or if it's one of the cities that are maintaining those roads, they'll just need to continue to incorporate those best practices. And taking that simplistic approach and talking about how difficult it is to monitor, like Stephen was going through, we know that this is going to be an adaptive management effort moving forward. So we can't say for sure how road expansions will affect things, but we're not handling them necessarily like it was in Illinois.
Okay. And do you anticipate creating more TMDLs for the more of the highly urbanized areas?
So it's our intent, at least at this point, that if the other MS4s and throughout the region there is a proactive adoption of these best practices, we hope that that can allow us to defer or potentially even avoid the need for TMDLs. As Stephen noted, a lot of our sampling also happens during summer months, and it's hard to capture these kinds of exceedances unless you really go about it targeted. In fact, the reason we missed a lot of these exceedances in our data beforehand was, when it snows, perhaps maybe that's not a good day to go out to the field. Well, because USGS was going out into the field very regularly on the same day, that's why we were able to see these exceedances. So they're hard to capture in our data, but again, it's our hope that we can defer or avoid them by proactive adoption from our MS4s and other stakeholders.
All right. And this one can kind of be for both of you. Did either of you ever meet resistance from regulated communities just through the development process?
Yes. It's one of the things I've noted here is these are always an experiment of one. Every agency is different. You have different personnel, different elected officials, different land uses, different equipment, different history. And I think, there's resistance sometimes from inside agencies that have been doing this the same way for 30 years, and they don't appreciate being told, that they need to do it differently. And I can understand that. So I think that's part of our voluntary approach, is where you can put the information out there and suggest that there are cost efficiencies. And one of the things that we have used to great effect is pointing out that we're in the business of trying to manage ourselves before we're managed from the outside. But yes, we do meet resistance, I would say, especially in some public works, people have been doing what they're doing, it's working, and they don't necessarily want to change.
And I think you said that really well, Stephen. We do meet some resistance from some regulated entities, but other regulated entities have stepped up and said, we see the problem. One of our stakeholders actually sits in the seat where he sees the impact on the wastewater side, on the drinking water side, and he also manages the salt applicators. And so, we see that resistance, but we're just trying to do our best along the way of saying, yeah, in a lot of cases this is voluntary. In the TMDL watershed, it's not. But it's the way the Clean Water Act works. We have to follow that process, but we're going to work with the stakeholders as much as possible to quell their concerns and, hopefully come up with solutions together. And there's been some relationship building as we've started this process, but it's all about meeting them in the middle, and so far we've been getting more successful with that.
Yeah, and I've one thing to add to that, just reinforcing what Will said. On the flip side of that, we do have a number of communities that have been just amazing about this. We have communities that have cut the amount of salt that they've been using by 50% over the period of this program, and they're great. They have excellent expertise, and it's good to get those people to talk to the naysayers, because obviously they're facing the same hurdles, and they're facing the same, they're doing the same work, and it's much more convincing to have, a street supervisor with 30 years of experience running a snowplow talk about this stuff than it is to have a, water quality scientist talk about it.
Exactly.
All right, thanks. And now, Stephen, I have a couple for you, focusing more on the NPDES permits. And so how did you use the TMDL to issue point source NPDES permit limits?
So the TMDL did not have permit limits in it. It basically issued that there had to be a certain percentage reduction, and it had that total, and then it had a small, area for additional increases. So it really didn't set out like a traditional TMDL where you might have waste load allocations, et cetera. It didn't set it out in that way. It was a relatively short document. So what we tried to do is try to get set out a uniform set of BMPs that are efficient, and that we know that if you adopt them over a dry salt condition, you can get to a 50% reduction. As I say, we're not a regulatory entity. If the regulators wanted to step in and issue that kind of directive as a clarification side to TMDL, that will be up to them. But I think at the moment we're showing that we're making reductions under our more voluntary program, and the state seems to be okay with that at this time.
Okay, and how did the DOT NPDES permit deal with the % reduction required in the TMDL? Was that still voluntary for them as well?
So, and I think we're talking about the Illinois Tollway here, which is the case study that I mentioned at the end. Yeah, so their permit set out, I believe, it's a little while since I've looked at it, but I believe it set out that they had to reach a zero increase type situation, and they're doing in-stream monitoring on top of the monitoring that we're doing, which is, looking at these variables, and we're looking at, perhaps a multivariate analysis that will allow us to smooth out these waxing and waning of chloride concentrations. But yes, their permit did set out that they were to run this program and they were to make their own reductions in order to have a no net increase type situation. So I guess that's not a load allocation in that sense, but the permit looked at a no net increase type situation.
Okay, just got a couple more here. Does brine have less of an environmental impact on biota compared to regular salt application, or is the brine preferred from a quantitative reduction perspective?
So, yeah, well, brine is preferred because, as I was pointing out earlier, it's agencies using that, you get figures we're seeing, it depends on the way it's used, but you can get from a 75% reduction, like a 40% reduction on the total amount of salt that you're using. So if you're reducing the amount of salt that you're using, then you're less impactful on aquatic life. But the active ingredient there, the chloride, is the same. It's just that you're using less of it with a liquids-based type streets operation over a dry salt operation.
Okay, and I've actually got one going back to the point source reductions. So why use a TMDL with no point source reductions instead of a 9-element plan?
Is that one addressed to me?
That might be sent to me. Part of the reason that we, first of all, we were going down the road of developing a TMDL, and we were developing TMDLs for the sediments, so we thought it logical to only go down the chloride road as well, because the impairments were going to remain there, and we had identified the stressor, and at that point, it's kind of the point of no return. But we did discuss the idea of maybe doing a TMDL alternative, and just knowing how difficult this issue is and learning how difficult it is to see immediate improvements, we were concerned that was going to leave us liable for not addressing an impairment with the TMDL. And so we went down the road of not putting % reductions on there, specifically because we didn't want any sort of third-party lawsuits or just any sort of legal liability on our regulated entities when it comes to not meeting the mark immediately. Again, the end goal is to get rid of the impairment. So we're going to keep monitoring that and adaptively managing our efforts to get towards there. But we got rid of the % reductions just so that there was a little bit of peacemaking there to quell any concerns, but also so that we could avoid any of those sorts of liabilities. That said, though, we still did use the water quality monitoring data that was outside of the TMDL assumptions in a separate chapter of the TMDL to say, hey, these are some target % reductions so that you can aim your operations towards this goal.
Okay, and this one came in during Will's presentation, but again, it can be applied to anyone. Did either of you see late summer spikes in chloride concentrations as the streams become more base flow dominated?
In Accotink, at least, there are a few spikes, none of which exceed the criteria, both the chronic or the acute. But that's probably more related to illicit discharges than anything. What we did look at, and I saw a lot of this in Stephen's presentation as well, is looking at those average summer concentrations, and we did see that over each year there was about a 4% increase in that average concentration. Keep in mind they're low concentrations, but they're still increasing. So we know there's a buildup in the groundwater and coming out in the base flow, but not necessarily in terms of anything that risks an exceedance of a criteria.
Okay, and were these TMDLs approved by EPA?
Yes. For Virginia, ours are still in the approval process. We kind of have a little bit of a convoluted process. So our State Water Control Board has approved them, which that has to happen first. EPA has given their provisional review of it and have no further comments, but they go to they actually go to the board in April, and then after that, EPA will weigh in on their approval. But as it stands now, they have no more comments for us, so we have confidence they should go through smoothly.
All right. I'm not seeing any other questions, so I think we'll end it there. If you do have any follow-up questions, you'll have the option to send those in through the survey that should pop up at the end. Thank you, Will and Stephen, for these presentations. Thanks, everyone, for attending. You will get a notification when the slides and recording are up on our website, along with the link.
Thank you very much.
Thank you.